This region question here, I can tell is says I've got four functions below. Okay, so I've got four different tables with basically X and Y values, and I'm trying to determine which one of these is an exponential function. So remember, when I see that word exponential, that means that this is going to be changing by multiplying. Okay. Um, it's not linear, so it's not addition or subtraction. I'm looking for multiplying values for it to either increase or decrease. Now, when I look through these, okay, as I first noticed that the X values are all just increasing by one. So really, my eye should be focused on the Y values, okay, and how these guys are changing. Okay. Now, if I look here, okay, just right away, this one here doesn't look to me like it is changing by multiplication. Okay. If I go from 6 to 7, that looks like I'm adding one. Okay. Then I'm adding three, then I'm adding five, then I'm adding seven. This one here, okay, is actually quadratic. Okay. The quadratic ones, we talk about something called the second difference. But sometimes it's easier to just kind of look at your answer choices and figure out which ones maybe look like they might be exponential. Okay. If I actually wanted to show that this one was not exponential and I didn't know if this was quadratic, I would be checking to see, okay, what do I multiply by from here to here? Technically, what I would do is I would take the second number and divide it by the number above it. Okay. So 6 multiplied by 7/6 gets me here. Okay. From here to here, same thing. 10 divided by the number before it. Okay. This is how I get from 7 to 10. These two fractions are not the same. Okay. So this one is definitely not exponential. Okay. Um, if I look at h of x here, okay, from 1 to 2, I'm doubling. From 2 to 4, I'm doubling. From 4 to 8, I'm doubling. Okay. Now, that same thing that I did over here, which might look a little bit confusing, okay, is I take a number and the term before it. 2 divided by 1, that's 2. Okay. I take a number, let's say down here, 16 divided by the term before it, 8. 16 divided by 8, oh, that's 2 again. Okay. Same thing here, 8 divided by the term before it, 4. That's 2. So that's how I know this one is exponential. That same relationship doesn't exist here. And I could check the other choices as well, but I can see that they're not going to work there. Okay. Um, G of X is actually also quadratic, which you might notice based on the symmetry here. And J of X, okay, me looking at that here is I'm going to say maybe that looks to be probably linear, is adding 3, 5, plus 3, 8, plus 3, that one's linear. Okay. So this is one of these skills that kind of visually you get better at the longer that you practice these. But honestly, my best advice wouldn't be to just start and test every single one, is maybe look at the one that you think is exponential first, especially since it's a multiple choice, and see if you can verify that one or not. Okay, because just visually, this one here just kind of has that exponential feel, is I can see that one looks like they're double. Okay, this one does not feel exponential. It's definitely not. It's increasing, then it's decreasing, and so on. Sorry, or decreasing and then increasing. I mixed that up. Okay, this one here, if I wasn't sure, I could check it. Okay, this honestly, this first one here is the one that I'm assuming most students would trouble with. So most students would probably be undecided between h of x and f of x, because this one is easy to prove that it's linear. This one looks quadratic based on that symmetry. And this one doesn't show the symmetry, but that one is in fact actually quadratic.